I'm Anna, and that jet, that supercar, and the sound were all created by one model running on a single computer. Now let's watch one more, and keep your eyes on the camera while it plays. That model is LTX-2.5, and today we're installing it together while I name every single box in this workflow. Stick around to the end as well, because there's one number in here that crashes almost everybody's first render. And before we get into it, if you're planning to actually build this along with me, hit subscribe first, because the image to video version of this workflow is the next one I'm making. LTX 2.5 comes from Lightricks, and they release the actual model, which means you download the files, they live on your drive, and you generate as much as you like, offline, forever. The powerful features of LTX 2.5 include creating video and sound together, maintaining consistent characters across connected shots, and amazing camera movement. The distilled version also uses fewer steps, making it practical to run locally. To use workflow, you don't need to hunt for a file anywhere, because this ships with ComfyUI. Click Templates, type LTX into the search box, and click the thumbnail called LTX 2.5, text to video, and the whole thing loads straight onto your canvas. ComfyUI will then tell you which models are missing and offer to download them for you. So take that option and let it run. If those downloads come back with a permission error, that's the gated page. So sign into Hugging Face and agree to their terms, and they let you in. Let's see the workflow nodes one by one. First, we have the Resolution Selector. This node controls the width and height of our generated video. We can select an aspect ratio and target size here, and it automatically sends the correct width and height to the LTX 2.5 workflow. For example, we can use a widescreen 16:9 format for YouTube videos. Next is the main text-to-video, LTX 2.5 node. This is actually a subgraph containing the complete video generation pipeline. Here we can enter our prompt, choose the duration, resolution, seed, and frame rate. We can also enable Prompt Enhance and select all the required LTX 2.5 models. Instead of showing all the complicated nodes on the main screen, ComfyUI keeps them nicely organized inside this subgraph. Now, let's enter the subgraph and see what is happening inside. First, we have the Prompt node. This is where our main text prompt comes into the workflow. Basically, we describe what we want to see in the generated video. Next is Boolean, Enable Prompt Enhance. This is simply an on and off switch. When it is enabled, the workflow can expand a simple prompt into a more detailed prompt before generating the video. Next is Duration. This controls how long our generated video will be. A higher duration means a longer video. Next is Width. This controls the horizontal resolution of the video. And this is Height. This controls the vertical resolution of the video. Together, width and height decide the final aspect ratio and resolution. Next is Frame Rate. This controls how many frames are displayed every second. In this workflow, we are using 24 frames per second. Now we have the UNET loader. This loads the main LTX 2.5 diffusion model. You can think of this as the main AI model doing the heavy work of generating our content. Next is the first VAE loader. This loads the LTX 2.5 Video VAE. The Video VAE is used when converting between compressed latent video information and actual visible frames. Then we have another VAE loader. This one loads the Audio VAE. It handles the audio side of the LTX 2.5 generation pipeline. Next is the main clip loader. This loads the LTX 2.5 text encoder. Its job is to help the model understand our written prompt. Next is the Latent Upscale model loader. This loads the special LTX 2.5 latent upscaling model. Later in the workflow, this model increases the video resolution while the video is still in latent form. Next is the first clip text encode node. This converts our positive text prompt into conditioning that the video model can understand. Basically, this tells LTX 2.5 what we want in the video. Then we have the second clip text encode node. This is used for negative conditioning. It describes things that we want the generation to avoid. Next is LTXV Conditioning. This prepares the text conditioning specifically for the LTX video generation process. It also works with the frame rate information, so the conditioning is correctly prepared for the video. Next is empty LTXV latent video. This creates the empty starting space for our video. It uses information such as width, height, number of frames, and batch size. The AI will gradually turn this empty latent into our generated video. Next is LTXV empty latent audio. This does something similar, but for audio. It creates the starting latent space where the synchronized audio will be generated. Next is LTXV Concat AV latent. AV means audio and video. This node combines the video latent and audio latent, so they can move through the generation pipeline together. Next is random noise. This provides the starting noise used by the diffusion process. The seed controls this randomness, which means changing the seed can give us a different result. Next is SamplerCustomAdvanced. This is where the first major diffusion process happens. It uses our noise, guider, sampler, sigma schedule, and starting latent to generate the first version of the audio-video latent. Next is LTXV Latent Upsampler. This increases the resolution of the generated video latent. The important thing is that we are upscaling before decoding the final frames. This helps produce a higher resolution final video. It is important to note here that we have two stages: low resolution generation and high resolution generation. The main steps we perform in the low resolution stage are repeated in the high resolution stage. The difference is that the first stage creates the initial video at a lower resolution. Then we upscale that latent and repeat the sampling process in the high resolution stage to refine it and produce the final video at a higher resolution. So basically, the low resolution stage builds the video, and the high resolution stage adds more detail and gives us the final quality. Next is VAE Decode Tiled. This converts the final video latent into actual image frames. It uses tiled decoding, which can make high-resolution decoding easier to handle in memory. So this is where our latent video finally becomes visible frames. Next is LTXV Audio VAE Decode. This converts the generated audio latent into actual audio. So at this point, we have our video frames and our synchronized audio. Finally, inside the subgraph, we have Create Video. This takes the generated image frames and audio and combines them into a video. It also uses the frame rate, which in this workflow is 24 FPS. The completed video is then sent out of the LTX 2.5 subgraph. And finally, back in our main workflow, we have Save Video. This receives the finished video from the LTX 2.5 subgraph and saves the result. And that completes the entire pipeline. Okay, enough talk. Let's actually create some videos and see what LTX 2.5 can do. For our first example, let's create something peaceful and cinematic. I'll use this prompt: a peaceful lake surrounded by green mountains at sunrise. Gentle mist floats above the water, while a small wooden boat slowly moves across the lake. Birds fly quietly in the distance. Soft golden sunlight reflects on the water, and the camera slowly moves forward, creating a calm and cinematic atmosphere. This should be a good test for natural motion, reflections, lighting, and smooth camera movement. Let's paste the prompt here. I'll keep the rest of the settings as they are. Now, let's click Run to start the generation. As the workflow is processing, you can see each node getting highlighted one by one. This makes it easy to see exactly which part of the workflow is currently running. The generation will take some time, depending on your GPU and the settings you are using, so I'm going to fast forward this part. And here we go. Our video has finished rendering. Let's play it and see the result. Wow, isn't this amazing? The motion looks smooth, the atmosphere feels natural, and LTX 2.5 did a really nice job bringing our prompt to life. Now, let's try one last example. This time, let's create something completely different. A cozy wooden cabin in a snowy forest at night. Warm light glows through the windows, while snow gently falls around the cabin. Smoke slowly rises from the chimney. Pine trees move slightly in the cold wind, and the camera slowly pushes toward the cabin. Peaceful winter atmosphere, realistic lighting, cinematic details. Let's paste this prompt here, keep our settings the same, and hit Run. Again, you can see the nodes being highlighted as the workflow moves through the different stages. This will take a little time, so I'll fast forward the generation. And we're done. Our final video has been rendered. Let's play it. Wow, this one looks great as well. You can see the falling snow, the warm light from the cabin, and the slow camera movement. And remember, all of this was generated directly from our text prompt. So, we tested LTX 2.5 with two very different scenes. And you can see how easily we can go from a simple text description to a complete cinematic video. And that's pretty much it for this workflow. If you enjoyed this video and found it helpful, make sure to like the video and subscribe to the channel for more ComfyUI and AI video generation tutorials. Thanks a lot for watching, and I'll see you in the next video.